Let's begin by completing the warm-up. We have two objectives today. First one, learn to write and identify equivalent expressions using fractions, decimals, and integers. The second one, learn to use the associative, commutative, and distributive properties to simplify an expression. Let's take some time to get those in our notes. Essential question, how do I use the properties of numbers to simplify expressions? Let's talk about the three different properties. The first one is commutative. Think about how you get to school and back home. Do you take the same route there and back? Regardless of the route that you take, the way that you get to school and the way that you get home, you go one direction, you turn around, and you come back. And it's still the same path. So it's the same idea with addition. If you have 6 plus 2 or 2 plus 6, no matter what order you're going in, it's still going to equal the same thing. Associative. Associations have a system or order to them, so they must stay in the same order. You may move the parentheses, however. So if you look at this closely, the numbers 8 plus 1 plus 5 are in the same order on both sides, but the parentheses are what have moved. So try to associate that with a group that has a leader, maybe a president, a vice president, a treasurer. They have an order. Distributive. Distribute means to share. When we distribute, we multiply both numbers that are on the inside of the parentheses by the outside number. Now in this case, there are only two things inside the parentheses, but there could be as many as we want. So you can see with x plus 3 in the parentheses, it becomes 5 times x plus 5 times 3. And then if we simplify that, we have 5x plus 15, which is as far as we can go. So let's get the examples of the properties written down, the names of them, and one example for each. These properties also apply for multiplication. So for commutative, if you take 2 times 3, that's the same as taking 3 times 2. Associative, if you multiply 2 times 3 times 4 and 2 times 3 times 4 with parentheses in different locations, you have the same order and it continues to work. Distributive, multiply the outside number, and then it could be addition or subtraction. So we might have 2 times 3 and 2 times 4 and then add them, or 2 times 3 and then 2 times 4 and subtract them. This table is also in your textbook. It shows the different properties and how they work for addition and multiplication. You'll notice that there are no division or subtraction except for the subtraction that's within the distributive property. Because if you think about subtraction, 10 minus 5 and 5 minus 10 are not the same result. Just like division, 14 divided by 2 and 2 divided by 14 are not the same result. Two properties we didn't mention are the identity property, which shows that in addition, if you add 0 to a number, you don't change the value. And if you multiply by 1, you don't change the value. So the identity property just shows what happens in order to keep the number the same. Zero property is exactly how it sounds. Anything multiplied by 0 equals 0. Equivalent expressions have the same value no matter which numbers are substituted for the variables. So both sides of the equal sign are the same. Let's see if these properties can get us to decide if the expressions are equivalent. So we're going to take 7 times x times 6, use properties to see if we can get it to equal 13x. Well, the first thing we could do is use the commutative property and rearrange those numbers so that 7 times x times 6 can be 7 times 6 times x. Now that we have those two values in the front, we can group them together using the associative property. And when we multiply, we get 42x. Is that the same as 13x? No way. The expressions 7 times x times 6 and 13x are not equivalent. Let's try another one. 5 parentheses y minus 11 and 5y minus 55. We have to start with the left phrase, 5 parentheses y minus 11, using the distributive property. So we multiply everything in the parentheses by 5. This becomes 5 times y minus 5 times 11. So 5y minus 55. Those two expressions are equivalent. Another distributive property. Let's see if 2 parentheses z plus 33 is the same as 2z plus 66. Before we start, take a guess as to if you think they're equivalent or not. Okay, when we distribute 2 times z and then 2 times 33 and we add them, we get 2z plus 66, so they are equivalent. One more. 4 times x times 3 and 7x. Again, make a prediction as to if you think these are equivalent or not. Use the commutative property to rearrange the numbers. 4 times 3 times x. Group them using the associative property. 4 times 3, you get 12x. They are not equivalent. Let's do some mental math. Dash tutors students and earns $9 per hour. How much money does he earn if he tutors students for 21 hours a week? We need to multiply to find the total. So we are really trying to multiply 9 times 21. For some of you, maybe you've already figured it out. But one way to break it down is to break it into easier numbers, such as 20 and 1. If you think of it as 9 times 20 and then 9 times 1 added together, you can easily get 180 plus 9 is 189. So distributive property can be used to make mental math a lot easier. Let's talk about two new vocabulary words. A conjecture is a statement that is believed to be true, and a counterexample is an example that shows that a conjecture is false. A conjecture is an educated guess that has not yet been proven to be wrong. And a counterexample is an example that we use to prove a conjecture is false. So let's find a counterexample to disprove the conjecture. The product of two whole numbers is always greater than either number. Product means multiply. Whole numbers would be anything from 0 1, 2, 3, the counting numbers all the way up, is always greater than either of the numbers. Okay? What if we tried 1 times 2 equals 2? So 1 times 2, our whole numbers are 1 and 2. The product is always greater than either number, but if the answer is 2, that is not greater than one of the two multipliers, which was 2. So we've disproved that conjecture. Let's see what we can come up with for this one. Find a counterexample to disprove the conjecture the product of two whole numbers is never equal to either number. Let's try 9 times 1. So again, we're multiplying two whole numbers. Our answer is 9, but it says the product of the two numbers is never equal to either number. But the product is 9 and it equals one of the two multipliers, which is 9. So again, we have disproved the conjecture. To wrap it up, explain in your notes what property you would use to simplify the expression 4 parentheses 8 plus 2. If you'd also like to work the problem out, go ahead. If you put distributive property, you are correct. We will use the distributive property quite frequently this year, so hopefully become very familiar with it. Think about the tasks you now need to complete. First, make sure your Cornell notes are filled out completely. Review your notes and complete the summary before class. Feel free to go back through and add any additional notes that you feel are necessary. Come prepared to take a formative, non-graded lesson quiz on how well you understood the material.